All right, so anyway, unit 0, we're going to flip to the first page here. And it's just front and then a little bit of a second page is all we're going to cover today. Hopefully it's, like I said, a lot of review, but also it's something we haven't for a while. Assuming most of you, a good portion of you, took Algebra 1 probably 2 years ago. Took geometry last year. You're slightly different, but probably 90% of you fall in that category. So we got to kind of review how to graph. And I know there's some of this in geometry, but it's not what we're looking for always. We got to hit it again. So the big thing here is our learning target is I want to be able to graph linear equations, just equations that are straight lines. And also, if I give you the equation, or if I give you the graph, could you give me the equation? Kind of going both ways with it. It's a goal. And there's a few different forms that we can use when writing these. So the first one is slope-intercept form. So for slope-intercept form, if you remember, it's y equals mx plus b. And the y and the x are part of the equation. The m and the b will be numbers. There'll be some number of values that we'll fill in that will give us a graph. So the m represents the slope, and the b represents the y-intercept. The y-intercept being where it'll cross the y-axis. And also, the y-intercept is what you get. Get my pins are dried up over the summer here. It's what you get, like your initial value. I'll put initial value. For when x equals 0. So if you let x equal 0, this is the y value. If you're plotting, the value over the car was made, this was the value. This was the initial value of the vehicle, whatever that might be. So that's your initial value, and then write this off to the side here. The slope is rise over run, which that's more specific to when you're graphing on a graph, like how far did it rise up, how far did it run, to the right. But in real life, just how is the y changing? So this would be the change in y compared to the change in x. So if x went up 2 units, what did y go up? And if it's a linear equation, this will stay constant. The slope will be the same always. So kind of that's unique to linear equations. So the first thing, if you remember, if it's in slope-intercept form, that's the two things you're going to use. You're going to use the y-intercept and the slope to graph it. And this kind of makes it a little bit quicker, and it's a shortcut if you do it this way. Because the other way is to make a t-table and plug a bunch of x's in and see what y's come out. And that's not fun. That takes a long time, and we never really want to do that. So one of the shortcuts is, if I let that 2, the y-intercept, the number on the end, again, this is what I get if I plug in 0, because what's 3 times 0? 0, and then plus 2 would be 2. So anytime I plug in 0, I'm trying to figure out where's across the y-axis. And that's true of all functions this whole year. So now, if you have second semester, all the way through May, if I say, what's the y-intercept, plug in 0x. That'll give you the y-intercept. The intercept on this is 2. So I'll go up 2 units on the y-axis and put it. And then from that point, my slope is 3. Now I need it to be a proportion, or I should say I need it to be a ratio. 3, 2, and then what would be on bottom? There's no number on bottom here. Like, what is over? Yeah, it's over 1. So think of this as a 3-to-1 ratio. I'm going to go up 3 units for every 1 unit to the right. And the reason why I know it's up is because it's positive. Okay. So from this first point, I'm going to go up 3 units from there. 1, 2, 3, and then go over 1 unit. And I want to continue doing that. So up 3 units over 1. And I ran out. Now, I can actually go the other direction, just do the exact opposite. If it's up 3, right 1, I can also go down 3, left 1. If I go from this last point I drew, down 3 and left 1, I'm back on the line. Down 3, left 1, down 3, left 1, and so on. You do not need to use a ruler. I'm just using a ruler so it looks straighter on the notes. But if you just draw a straight line, you're best. Okay. So try letter B. I'll actually pause my video and have you guys try letter B. All right, so we'll, again, start at 5. That's your y-intercept. And then from that point, up you write 4. 1, 2, 3. So right now I could just connect it since I have a ruler. Again, if I do it freehand, I try to just go on 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. So it should look something like that. Okay. Now how about that last one? There's only one number on there. So it doesn't have a y-intercept, so if it doesn't have one, what is it? The origin. Yeah, the origin, yep. It's the same thing as plus 0. A lot of times, we just don't write it. So C, since it's not there, like it flat out doesn't exist 0. So this one's going to cross the origin. Now, when this is a negative, we're going to go down. And it's notice I always go to the right. That's just, you always have to go to the right if you're doing rights over run like this. And then out of space, you have to do the opposite to the left. So if I'm going to go down to the right, I can go up to the left, get the same slope. So down 1, right 2, down 1, right 2. Something like that. There we go, y'all. Good. So how do we feel? So just walking around, I saw a lot of people had this, and they started doing that, and they were on the right tracks. That's good. It's a good sign. Because eventually in Unit 1, we have to draw 2 on the same graph and look for loss. And the hardest part is when I have students who can't graph, or you can't do step 2 if you can't do step 1. So if you guys are good at step 1, that's going to be good. Down below here, so go into a different form. Okay, so that was slope-intercept form. Really, that's probably the easiest, one of the easiest ones to graph. If I'm going to say graph this, if I'm being nice, I'm going to put it in slope-intercept form. If I'm kind of being a jerk, I'll put it in standard form. And I will do that to you, I'm sorry. So slope-intercept form is the easiest one to graph from. And standard, to be honest, I have no idea why we even do standard form. It's one of those things that all through math, we have a standard form, and then you change it to something else to do what you want. But that's how it is. So standard form itself, instead of having y by itself, y equals everything else, you have some coefficient, whatever the coefficient is in front of x, plus whatever the coefficient of y is, and then that equals the constant on the other side. So it's basically x plus y equals number. That's what standard form is. So if this is slope-intercept form, and I want you to write it in standard form, I need the x term with its coefficient to be first. So if right now 6x is on the side of the equation, I want it on the left. So if I want to move it to the left side, what do I need to do? So I subtract it. So I'm going to subtract 6x from both sides. That means when I bring it over, it'll be a negative 6x. It'll be minus 6x. So negative 6x. And that y is okay where it's at. It's supposed to be on the side. Y is supposed to be on the left side, so I'm going to leave it alone. Don't change it. It's plus y. And then 8 is still on the right side. So try this guy. So get that in standard form. Same sort of thing you did on the first one there. So the negative 2/3 x, it needs to go to the other side. So I'm going to add it to both sides. When I add it, it'd be 2/3 x plus y equals 5. So if we gave you in standard form, could you get it back into slope-intercept form? That's going to be something we do on the back side eventually. Maybe not the back side, maybe tomorrow. Tomorrow we'll do that, but if we only get y itself, you'd bring the 6x back to the right side, and it would be the original question then. Okay. So now, the one good thing that this is for, and like I said before, I don't know why we do it, but there is one way of graphing that form is good for, and it's if you want to find the intercepts. And sometimes it works out nice, neat whole numbers, and sometimes it doesn't. But if you want to find the y-intercept, what did we say above? We said the y-intercept was the initial value. You plug 0 in for x. So here, when you're trying to find the y-intercept, we're going to plug in for x. So plug 0 in for x and evaluate. The reason why we do that, if you think about any y-intercept will be on the y-axis. So if I pick a point on the y-axis, so say like this point right here, I'm just going to point to it. What's the x coordinate of that point? How far to the right did I go to get to that point? 0. And that's why I plug 0 in for x. Because anything, if I pick a different one, let's say pick that one right there. It's between -5 and -6. What's its x coordinate? 0. So if I plug 0 in for x, I'll find out where it is. Now, pick a point on the x-axis. So just a random point. That's between. What's its y value? How far up did I go to get to that point? No. So if I'm on the x-axis, how far up did I go? 0. Yep. Kind of a redundant answer, isn't it? 0. So if I want to find the x-intercept, plug 0 in for y and solve for it. So if I want to find the x-intercept, I'm going to plug 0 in for y and then evaluate. And that works for all functions the rest of your math career. If you want to find the y-intercept, plug 0 in for x. If you want to find the x-intercept, plug 0 for y. Okay, so like this one right here, it says graph from standard. So these are in standard form. Have something x plus something y equals a constant. And it says down here, graph each of the following by finding intercepts. So if I want to find the x-intercept, I need to plug 0 in for y. Now the quickest way to that, if I plug 0 in for y, 0 to 4 is 0, I just knock that term out. If I get this away right. So if I knock that term out, I got 5x equals 20. If I solve for x, it's 4. So when I plug 0 in for y, I got 4, so that's the coordinate 4, 0. Because x is 4 when y is 0. If I want the y-intercept, I need to plug a 0 in for x, which 5 times 0 is 0, so really just cover that term up. A textbook I taught from that had pictures of fingers covering up. They have a big fat thumb covering up the terms. Like my fingers are too big. But if I try to cover up 5x, it just leaves the equation 4y equals 20. And you can solve that then. So you really don't even have to plug it in, just cover it up. Like if I cover this up, x equals 4. If I cover this up, y equals 5. And we said earlier, in order to graph a linear equation, you just need minimum 2 points. We said 2 is good, 3 is better, but 2 is the minimum. Why have 2 points? So if I go to 4, 0, and then 0, 5, and then I connect those 2 points, that's a linear equation. I don't trust myself, so I'm going to use a ruler. So try part B. Find the intercept, find the y-intercept. I'm going to tell others, you don't have to. I mean, I have the luxury of having pens up here using, but find the x-intercept and the y-intercept. Okay, so while I was recording that, my microphone stopped working. So I'm going to be splicing 2 videos together here, hopefully, and to finish this. Got all the work done. I'm just going to explain it as we go. So I believe when I started off, we were trying these intercepts. So I went ahead and I fit it, and I found if I cover up this guy, cover up the x, I get -7. If I cover up the y, I get -3. Plotted those points, connected them, and that's the other part of that. Now flipping this over then, the backside, this is done for us, but I'm going to kind of explain it as I go, and I'll uncover it as we go. But it says to write the equation through these 2 points right here. In order to do that, I need to find the slope and the y-intercept. If I knew those 2 things, I could write my equation. So on this, the easiest thing to find if you have 2 points given is to find the slope between those 2 lines. And remember that the slope is the change in the y's, that goes on top, over the change in x's. So if I look at my y's, and you can label them however you want. I just did the first point, x1, y1, and the second point, x2, y2. If you flip-flop them, it'll still work. I just always do whatever the first point they gave me is the first point, whatever the second point is, that's the second point. So if I plug these into the formula, 16 minus negative 9, so minus and negative is actually plus, that's 25, and then negative 2 minus 3, so negative 2 minus 3 would be negative 5. And if you divide that, you get a slope of negative 5. So I plug that in right there. Okay, so I plug that in. That's my m. Now to find my b, I need to find, I'll cover this up for a second, I need to find an x and a y that makes this equation true. The fact that the equation goes through these 2 points means either one of them make it true. So you can pick whichever you want. It doesn't matter which one as long as you plug the y in for y and the x in for x. So on this one, I chose negative 9 for y, 3 for x. I plugged them in, and now I'm going to evaluate and see what I get. So negative 5 to 3 is negative 15. So if I add 15 to that, that'd be 0. So at least b on the right side. So if I add 15 to that, I get 6. So that's what my b equals. To answer the question, we have to put it into an equation in slope-intercept. So I plug my negative 5 in for x, and for m, and my 6 in for my b, and that gives me my equation, y equals 5x plus 6. Now, had I used this point instead, because when I plugged it in, I plugged in 3 and negative 9. Had I plugged in negative 2 and 16, I get the same b value. So it really does not matter what you pick. You can pick whichever one. They both make the equation true, so they will both find the same b value for you. Okay, so that's it on this. I believe the assignment is in Delta Math, at least the year that I recorded this video it is. So go ahead and open that up and get working.